All right, welcome to Unit 12. We are going to be focusing on graphing sine and cosine functions. Starting today, we are going to focus primarily on what happens if you change the amplitude or if you reflect a sine or a cosine function. As you can see here, this is our plan for the next 5 weeks. Eventually, we are going to add in there vertical shifts and midline. We will be doing frequency and period changes. And then we will end with going the opposite direction where I give you a graph and you have to tell me the equation. So graphing sine and cosine. Trig graphs are considered cyclic or periodic. And that's because there's a pattern and it's repeating y values over specific intervals. So when we use either a unit circle, which we learned way back. If I have a unit circle, this point here is 1, 0, 0 up 1, negative 1, 0, and 0 down 1. And so since this is 0 degrees and 360 degrees, up at the top would be 90, this would be 180, and down under would be 270. We could also convert those degrees into radians. So pi over 2 is the same thing as 90 degrees. Pi is 180 degrees. 3 pi over 2 is 270 degrees. And 2 pi is 360 degrees. We are going to pretty much always be, oh, look at that right here. We are pretty much always going to be labeling in terms of pi when we are graphing. So we're going to kind of get away from talking about degree measures and talk about in terms of pi. So when we are going around our unit circle, let me change up my color real quick. If I start at 0 degrees, remember cosine comma sine, sine is 0 at 0. When I work my way up, cosine comma sine, at 90 degrees, sine goes up to 1. If I work my way around here, cosine sine, at 180 degrees, that's back to 0. Then we go down to negative 1, and then we make our way full circle back up to 0. So if I go and graph these blue points on a grid measured 90 degrees, 180 degrees, 270 degrees, and 360 degrees, remember at 0 it was 0, at 90 it was at 1. 180 was at 0, 270 is at negative 1, and then 360 is back to 0. So actually a sine curve makes this sort of S shape, and that's going to be sort of our basic shape that all of our sine curves are going to take. So here's how we are going to be graphing sine. There's going to be a specific way that I'm going to have you label. So every single time you graph a sine curve, what I'm going to have you do is label 0, 0, and then skip 2 lines, and on the third line label that pi over 2. So that's going to be labeled as 90 degrees. Then you're going to skip 2 more lines and label that pi. That's going to represent 180. Skip 2 more lines, and that's going to be 3 pi over 2. So there's your 270. And then lastly, skip 2 more lines and label that 2 pi. That's going to be 360 degrees. So I'm going to label my graphs this way every single time. The directions tell me to graph sine of x from negative 2 pi to 2 pi. So actually I'm going to repeat this going the other way. So 2 spots to the left, and that's going to be negative 90 degrees. 2 more spots, and that's going to be negative 180. 2 more spots is going to be negative 270, so 3 pi over 2. And last but not least, negative 2 pi will be negative 360 degrees. If we follow the same pattern that we did at the top of the page, I will at 0 be at 0. At 90 degrees, oh, I forgot to label my x-axis or my y-axis here. My y-axis, let's skip a line 1, skip a line 2, skip a line 3, negative 1, negative 2, negative 3, and there we go. So at 0, it's 0. At 90 degrees, we're going to go up to 1. At 180 degrees, we're back down to 0. At 270, we go down to negative 1, and then by 360, we do 1 full sine curve. But since the directions want me to also go in the other direction, think about going around our unit circle in the reverse way. So if I started at 0, 0 and I went down, clockwise along the circle, it actually would go to -1. Then if I continue around my unit circle, I would make my way back up to 0. Keep going around your circle, you're at now a +1. And finish your full 360, you are back at 0. So a sine curve continuously goes and flows in this up and down motion forever in both directions. So when we are talking about domain of a sine curve, it actually would be all reals because it goes forever. However, I did restrict the domain in the very beginning of this problem, so you could also claim that the domain is -2π to 2π because that's what I told you to graph it from. The range is, remember, the lowest point it goes to the highest point that it goes, so that's going to be from -1 to 1. It is increasing multiple times, so let me grab a different color here. Let me use green. It increases, you always read a graph from left to right, so it's increasing from here to here, it's increasing from here to here, and it's increasing from here to here. So anywhere you see green on my graph, that's where it's increasing. So you would write that it is increasing from -2π to -3π/2. That's one of the spots where it's increasing. It's increasing again from -π/2 to +π/2. That's this part right here. And then the last part that it increases is from 3π/2 to 2π. It is decreasing. Let me grab maybe yellow. I think that's the only color I haven't used yet. It's decreasing along the graph along that interval and that interval. So it is decreasing from -3π/2, ooh, that's hard to see, to -π/2, and from π/2 to 3π/2. Yeah, that is hard to see, so sorry about that. All right, now, what you might notice is this curve that we just graphed here kind of goes up and down and up and down, and it kind of weaves up and down along a center line. So it is kind of going up and down and up and down across the x-axis right now. But eventually that x-axis is going to be moving. That line that it's kind of going up and down, that horizontal line that is halfway between the max and the min is called the midline. And usually it is y equals 0 because remember, horizontal, hoi. Eventually, however, the midline is going to move either up or down, so it's going to be y equals a specific number, but we're going to focus on that more tomorrow. I should say next time. The amplitude is actually something that we are going to be messing with today. Now, this is your basic sine curve, okay, y equals sine of x. But what's not being written there is a 1 in front of the sine. That 1 is going to be what we call the amplitude. It is always going to be a positive number, and so the amplitude is a 1, and that's why our graph hits a maximum of a 1. But if I change my amplitude to, let's say, 2 or a 5, then that means my curve is going to get much taller and it's going to go up to 5 or it's going to go up to 2, whichever I decide to change my amplitude to be. So let's actually graph sine of x over the same interval, but this time it has an amplitude of 2. So now instead of only going up to 1, it's going to take the exact same shape, but it's going to go up to 2 instead. So if we want to label just like we did last time, we skip 2 lines. We start at 0, 0, and then 2 lines, and this is π/2, pi, 3π/2, and then 2π. And you're going to get the hang of this because we are going to do this probably 50 times in the next few weeks. So you will get the hang of the order of the numbers, I promise. All right, so here we go. We got our axes labeled, and it is going to take the same shape as the last one did. So sine always looks like an S. A sine curve pretty much looks like an S. It starts at 0, 0. It starts on the midline at 90 degrees. Okay, so that's this point. At 90, it's going to hit its maximum. So at π/2, we're going to go up to our amplitude of 2. Then it starts coming back down and hits the midline again at 180. Then it goes below. Using that same amplitude, we go down to -2. And then lastly, our fifth critical point is going to be at 360 degrees. So every time you draw a sine curve or a cosine curve, you should have 5 critical points, okay? And I highlighted them here, 1, 2, 3, 4, 5. And you're going to follow that same curvature to repeat it going to the left. So if this part of the curve was on its way down, then that means at negative 90 it should be below at negative 2. Then it's going to curve back up and go up to 180. Then it's going to keep going up to positive 2. And then it's the only way that it can go is back down, because remember 2 is our maximum height. Domain, again, I had restricted domain in the beginning, so you could say negative 2 pi to 2 pi. And your range is bottom to top. So now that our amplitude is a 2, we are going to go from negative 2 to 2. I'm going to skip increasing and decreasing just to save us some time right now, but it would be the exact same intervals as the last one that we just did. And the equation of the midline is still going to be y equals 0, because we haven't shifted that yet. That's not happening until next time. So the last sine curve that I want to graph today is negative sine x. So now what happened was this 1 out front is now negative. The amplitude is always positive. So my amplitude is a 1 still for this problem. However, the negative is actually going to reflect our image. So the negative actually, all right, so let me switch my color again and label my axes. So I'm going to go up to 1 and down to 1 and pi over 2, pi, 3 pi over 2, and 2 pi. And if you notice, it only has me go from 0 to 2 pi this time, so I don't have to do the left-hand side anymore. When I am making my sine curve, what normally looks like an S this way, okay, now that my amplitude is negative, instead of hitting a positive point on the first run, it's actually going to go negative and then positive. So I actually am going to be graphing my little diagram of my red sine curve there. That's the one that I'm going to be graphing on my axes here. So again, I have 5 critical points. 1, 2, 3, 4, 5. Those are the 5 points that I'm going to now transfer onto my grid. So 0, 0, it still starts. Now it's going to go down to negative 1 because it got reflected, then to the midline, maximum, midline, connect with a nice curve, no shark teeth, nothing should be pointy or sharp. And that is what a reflected sine curve looks like. On your homework, you guys are going to take this reflected sine curve and add an amplitude to it. Okay, so I know you can handle it. I know you can do it. Domain this time is from 0 to 2 pi, and my range is from negative 1 to 1. It is increasing, and I'm just going to color it in. It is increasing from this point to this point, and it is decreasing from this point to here and this point to here. Okay, so if you want, the decreasing was green and the increasing was blue. I'm just going to save us some time from that. And as before, our midline is still 0, y equals 0. So that's what a sine curve looks like. A sine curve looks like an S. A cosine curve, however, does not look like an S. If I bring out the same unit circle that we used on our sine curve, so let me use this space here. All right, so if I have my nice little, oh, there we go. Maybe it won't let me because it's on 2 different pages. All right, so this was 90 degrees and that was 0, 1, 0. This is 0 up 1. Negative 1, 0. 0 down 1. And we learned way back when we were in class that our coordinate points are cosine, sine, cosine, sine, cosine, sine, cosine, sine. So when I go around my curve, at 0 degrees it is 1, at 90 degrees it is 0, 180 it's negative 1, 270 it's 0, and then 360 we're back at 1. So this is 0 and 360. this was 90 degrees, this was 180 degrees, and this was 270 degrees. 0, 90, 180, 270, 360. So going around our circle, starting at 0 degrees, cosine was 1, 0, -1, 0, and 1. So it starts and stops at the same value. So cosine has 5 critical points as well. At 0, it's up 1. 90 degrees, it's at the midline. At 180, it's below the midline. Then it comes back up to be on the midline, and then it reaches back up to its maximum. So if you can squint or abstractly look at it, cosine kind of looks like a weird open C. So remember, sine makes an S shape, but cosine kind of looks weirdly like a C, but a lot of my kids call it like a valley, or I don't know, a trough or whatever. Valley probably works for most of you. So let's just replicate the same thing we just graphed there at the top, because it was already kind of done for us. We're going to label this the exact same way we label sine, which is kind of nice. That means you don't have to change your thinking when you're graphing sine or cosine. Our labels are always going to remain the same. And I know I'm labeling this really quickly. Feel free to pause this video if needed so that you can label yours so that you don't get behind. All right, so it wanted me to graph from -2 pi to 2 pi. I am going to be graphing in my red pen, so let me go back to that. All right, so at 0 degrees, cosine is up 1. At 90 degrees, cosine is at 0. At 180, it is at -1. Then it comes back up to the midline, and then we go back up to our maximum. So here is, and I know it looks like you could make it nice and pointy, but I want you to try and make it rounded. That is one full cosine curve. It also wants me to graph it to the left. So if I continue this down, this would be my next point. Then the only way for me to go is down below the midline. So here's that half. Once I hit my minimum point, I make my way back up. And then lastly, all the way, and I finish at my maximum. So that would be 2 full cosine curves. This is one full cosine curve. This is another full cosine curve. This has an amplitude of 1. We just learned that. That is an amplitude of 1. It is hovering around our midline of y equals 0. It has a maximum of 1, a minimum of -1. Our domain is from -2 pi to 2 pi. Our range is from -1 to 1. And again, if you want to take the time to list out the intervals of increase, you just kind of follow along the curve. Okay, well that's going down, 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 but once I get to this point, that part increases, then it goes down again, and then from here to here it increases again. So anything I didn't label blue that is still red would be considered a decreasing part. All right, well, let's see what happens if I change the amplitude of a cosine curve. It's actually the exact same thing that happens if I change the amplitude of a sine curve. So this time our amplitude is 3. So when I graph this, I go up 1, up 2, up 3. Now I personally, this is a personal choice of mine, I skip a line just to show that there is separation. If you don't skip a line, you are not wrong. Pi over 2, this is pi, this is 3 pi over 2, this is 2 pi. Go the other way. -90, -180, -270, and -360. All right. So we know that our standard cosine curve looks like a valley. It has 5 critical points. 1, 2, 3, 4, 5. What we need to do is replicate those 5 critical points onto our grid, but using an amplitude of 3. So our first point starts above the midline at our maximum 3. So that's going to be our first point. Then after that, we go on the midline. So at 90 degrees, we're going to be on the midline. Then at the point after that one, so at 180, we should be down below in the length of the amplitude, so 3 below. Then we go back up to the midline, and then our 5th point should be above, back to our maximum. That is going to give me 1 full cosine curve. Try not to make it too pointy at the bottom. And then you literally just follow that same pattern going to the left. So midline, minimum, midline, maximum. Lots of M's. There is our cosine that has an amplitude of 3. You can almost think of it as a vertical stretch. That's really what it is. Our domain is the same as before, negative 2 pi to 2 pi. Our range is bottom to top. Increasing, decreasing, I'll save us that time, and our midline is still y equals 0. So the last thing that we are going to be covering today is what happens if I reflect cosine. So if I reflect cosine, what did look like a valley, okay, if I reflect that, means instead of starting at the top, I'm going to start at the bottom, and it's going to almost look like a little mountain. So let me get rid of that one. It's going to look like a little mountain. Some of my students call it a ghost, whatever you want to call it. So label again, pi over 2. Like I said, we're going to do this so much in the next few days. That should say pi. This one's 3 pi over 2. I must have pressed a button. I'm sorry. 3 pi over 2. Yeah, I press page up. All right, and our amplitude, remember, is always positive, so our amplitude is 1. However, our curve is being reflected. So instead of starting at a maximum, we're actually going to be starting down here at a minimum. So when I go and label this, so negative 1 and 1, when I go to make my first point, it's going to start at the minimum. Then we're going to go to the midline. Then we hit our maximum. Then back to our midline, and then lastly back down to our minimum. So it's going to be this nice curve through all of those points. Domain would be 0 to 2 pi. Our range is bottom to top. Same, you guys can figure those out. Our midline, our maximum, our minimum. So remember, maximum is just the highest point that the curve goes, and minimum is just our lowest point. So that should be enough for you guys to be able to complete our homework for tonight. Please use your notes when filling out your homework. But you got this. I'll see you next time.